Okay. Desmos, here it is, x squared. X squared moves up. Does that make sense to you guys here? So if we want to change this around, actually, no, if we want to make it even tighter, are we good there? Like that? That's the difference between a 2 and a 3, or a 2 and a 1. And then if we want to turn it upside down, all we got to do is do this. Everybody good there with that? It kind of changes things up. Okay. So what happens if? Here's what I'm going to do. I'm going to add x to the 4th now into here, plus x to the 4th power.
What? No.
Interesting. Still going the same direction or no? Sheesh. In fact, if I change this to the 3rd power, notice changing this guy does not change that much.
That's not okay.
Right?
That's
not okay. That doesn't make
right there, bro. This man chased me with a knife. No, that's not fair.
Why is it like wonky?
Why? This one is perfect. So if I go to the 4th, everything, notice if I change this one though, then things change, right? That little, notice it's the higher coefficient that sort of changes stuff. And so let's see, if I add another, let me add this, right? Let me add x to the 6th power.
Minus. What do you do?
Minus. Okay, I'll do minus.
What?
Notice it's still
It's starting to
similar. We
get
good?
backwards.
Yeah. Let's see. Minus a 3.
Oh.
Minus 8 brings it down. Multiply this by 2.
Can you square root the second half of that?
Don't want to do that.
Or can you divide it by?
If I change this 5.
Divide the whole thing by x.
No, not yet. If I change this to a 5.
No.
Guys, real quick, if I change this to a 5, notice it's still similar, right? It's still facing up. We good? So now notice if I go over here and I go like this, so minus. Ooh, that is going to affect it, right? So notice the stuff inside here, that little plus x to the 3rd. If I make it to a minus x to the 3rd, doesn't change. It's kind of like the in behavior of the graph. We good? It's still facing down or facing up. It's this little piece right here that shifts things. And how about if I make it into a 2? Oh, sorry. Bend real quick here. 3, 4, 5. Notice it's still facing up though. That's what I want you guys to see.
Throw in random like.
But it's this little piece right here that actually kind of dictates us. Oh, hold on. How about this?
Second half and put it to the power of x.
No, not yet.
Divide the first half by it.
Yeah.
Not yet.
Divide it by a negative. The power of negative x.
What I want to do is change this to let's see. I'm going to make this a 4. And I'm going to change this into a 5. Just want to see what happens here. What happens here? I'm going to go with the 5.
Oh,
there we go.
Back to 6.
That's funky.
Back to 5. Ooh, there's a little change now, huh?
What happens if you do 4x4
Weird.
for the second part?
that is not how graphics work.
4x4.
Someone just.
What if you made it a 3?
A 3. A 2.
Make it like a 10.
It's like 100. I don't know.
If I change this 5 to a negative 5, what's going to happen? It's going to flip, huh? So as expected.
What? But it didn't. What?
That's normal.
It changed. It did more than flip. It changed.
What if you made it 1/5?
It didn't change. That looks like a normal graph.
The center part stayed the same.
So again?
Like the closest point stayed the same.
Mm-hmm.
Hey, what if you made
They just
1/5
flip.
X?
Say again?
1/5 X of 5.
Oh, 1/5 x. So 1 divided by 5.
What? Let's go, West.
No.
Yes, sir. That's how you do it. See, you gotta listen to my suggestions too, because then it'll get really fun.
Okay. So I'm going to back to 5. We're going to go with Jaden's suggestions.
Yeah, take the from the 2x to the 3rd.
One second. Let me
Everything
zoom
to the
in.
right of that. Put in parentheses and put it to the power of x.
When graphs are kind of.
Gets all crazy now. Okay, what are we going to do?
So from the 2x to the 3rd and
2x
everything
to
from
the
there to the right, put in parentheses and put that to the power of x.
What?
And then take the first half that you didn't put
Okay.
in parentheses and
So-
divide it by x.
To the power of x?
Yeah.
He doesn't let you do that.
And then the first half of the equation.
Is that
Can you put
what you
the first half of that divided
I like
by
that
It's gonna be a straight line.
I like that graph. That is a good looking graph.
In this right here, divide that by x?
That graph
Yeah.
is not straight.
Why is it so hard?
It is straight.
I know.
How did that work?
It's too small to see.
What?
Uh-huh.
It's not straight.
Ow.
All right, there's Jaden's graph.
Literally, bro.
Oh,
What is
I
that?
was lied to.
I don't know.
I was lied to.
How is it just a straight
Scam.
line?
It's
not
not
a straight
though.
line.
I know.
Jaden?
It is,
It's not.
bro.
I can see a little rhythm.
That
Just
is
cancel everything out.
beyond foul view. That's not
Oh, cool.
Why is that possible?
Wait, I haven't had that.
Sorry, Jaden. We're good there with yours?
Alright, no
Everything's a lie. Graphs are a scam.
I know. Why did it do that for?
Replace 3x with the square root of -1.
I hate the math.
Or square root, I was thinking suspicion, I bet doesn't like this. I don't know, just a little. -1.
I don't know. You guys, all crazy stuff here. Miles didn't work.
Can you just do something cool since you know math? Can you how do you make it go in a circle?
Oh,
we've done
can't,
that.
but you gotta do it.
We did this last
You
in
can,
algebra.
we can do a circle
I know,
pretty
not a circle,
easily.
but
I don't know
a
how to.
loopy circle.
A loopy circle.
No,
Like a swirl.
Oh, like
You tangent.
like a
Accurate.
flower. Like a flower.
A flower.
very, very
Alright.
on brand. Very on brand.
For Jaden, we'll do a flower. We good? So how about
That's
this?
all I need to see. Oh wait,
So we have these grids, guys. X and Y grids go like this, rectangular grids. If you change to something called polar
I get it.
coordinates, they gotta go like something like that.
Oh.
It's crazy
I
stuff.
love polar
And
coordinates.
specifically,
no,
Oh,
no,
what?
no.
no.
Oh,
That's not right.
Can we learn how to do this?
Yeah, it's so fun here. Yes, Jaden. Next year we'll learn how to do this here.
Oh.
So I need to do theta. I think that's how it goes.
See, can you put that stuff in a regular one? And see? I think that's how you make weird shapes, right?
Except white theta does not work. It should be. That's X.
There you go.
No, heck, nah. To the heck.
Uh-huh.
To the heck.
That is an X and Y coordinate.
That's still an X and Y coordinate system.
Now, plot the
How do you make
coordinates of this graph.
around the origin?
Now, please plot the coordinates of these graphs. At
Should be
every point.
theta, but I'm not sure why theta's not working.
Intercept, range.
Yeah, I told you. This might
The there's spelling in math. What? Not okay.
T? I don't think so. Let's see.
I'm like, I
That's
see
weird.
the,
I'll have to
I'm
look
like,
at.
only
Jaden, I'll have to
right
find out
thing.
why that's not working.
Like
Should be just
What
theta.
color
It's
is
like this around the origin.
Yeah, it should be theta on here, but there isn't.
I'm
no
still
theta here.
trying to understand.
I'll look it up. We'll make a flower for you. Okay.
Thank you.
All right. So let's go back real quick here. Let's jam back to here. So I think Jill said it correctly here. We have a few little things here. If we have x to the even power. So whatever happening in the back, it does not matter. It's just the front, this little beginning part right here. So it is x to the, thank you. Oh, you know, let's put an a in here. Ax to the n is odd. We're gonna have to the fifth power, right? So we kind of do like this here. It's gonna start off low. I'm not sure what happens here, but eventually I know that it's gonna end up going high like this. We're good. As long as a is greater than 0. So sometimes this is called the end behavior of a graph.
Does that need to have an A? If A was just 1, then would it still do that?
Yep, phase 1 still does it. Yeah.
So basically, with those conditions, and it's odd, A is more than 0. One side must go up, one side must go down.
Yep. If a is odd. We jump to the next one here. We go x to the a is
You go back.
and a is less than 0.
I don't feel safe anymore.
So if any odd, then the graph is going to go lower left. Thank you.
Keith, good?
Yeah.
Cool. And then if we switch a around, then what tends to happen is we start off high or up or right. I'm not sure what happens here in the middle, but I know that it's going to end at the lower end
If
here.
it's even, it's like that.
And even,
Oh, okay, so this new graph is if A is smaller than 0?
let's check.
I'm just curious, when you drew this new graph, what is that? Is that correspond to?
If A is less than 0, so if A is negative value, then what happens is it shifts it over. So it starts up high, ends low.
Is that like specifically in the second quadrant or just on the left side?
Yeah, on the left side, but it is, if it's going up high, it will be the second quadrant. So this one, if you guys think about x squared, right? X squared is gonna start, it's gonna start high. We usually call it like start high and end. It's gonna end high again. Just like x squared would, right? In behavior, start high, end high. Yeah, fine.
So, are you saying that, okay, is it just n that's odd, or is it ax to n power, and it has to be odd? Because in one of the slides you said n odd instead of ax to the n.
Yeah, sorry,
odd.
n is
Okay,
even.
okay, so
Thank you. There it is. Sorry, n is right here. I started going a little fast here. And one last one, we're missing one here.
Yeah.
N is even and A is
Equal to or greater than?
we know if X is
And it's even in A is greater than A is.
perfect. Yeah, one last one here would be like this. So we have AX to the N is even. And A is gonna be less than 0. So how does that graph look like here? Yep. We're gonna start off, we're gonna start off low, and I don't know what happens in the middle, but we're gonna go low as well. Okay. So again, what is this section about is just being able to graph these guys. Yep. Just a second here, and Tony and Eli going back here, go. So let's do this here. I'm gonna put up a graph. You guys just tell me, starts high, starts low, ends high, ends low. We good? That's all we need to do.
To the previous slide.
As soon as we're done here.
I think we've probably gone over this already, but we have like a definition of even solid.
Let's see, definition would be even would be a number that 2 goes into it evenly. That's the proper definition of it.
Oh, so yeah, okay.
It's just n, it's not the whole part.
Oh, we have like some weird definition of even. So this is just like regular.
Okay, we're good there. Next one, here's that one. And so this is called in behavior leading coefficient test. So tell me what is happening with this graph here. How does it start? How does it end? If I have a graph that looks like this. So I want to start and I want to end, and it's either high or low.
Starts high and slow.
Everybody good with that? Starts high. Ends low. And which one is it? Let's see. Let's go back in our little notes here.
If n is less than 0 or less than 1.
If which one? It feels it'll be squared function then. Yep. If we go back in our notes here, it would be what? Even, odd. It would be this one right here. Is that right? If that makes sense. You guys good there? This is you have an odd leading coefficient, and A is going to be less than 0. So it's A is a negative value there. One more, then we'll move on. We'll start putting all this together here. Exercise 2. Oh yeah, how about this? I'm writing all this stuff at the end, but that's just gibberish anyways, right? So all we got to figure out is this and this. Everybody okay with that? Yeah.
So the main focusing on is like the first, the reason why it's high is because it's 2 and 6, right? I'm just making sure.
Yep.
Like that's the things that we should go.
That number and that number, that's all we need.
Got it.
Uh-huh. And sometimes on the book, I'll say, what is the right-hand behavior or the left-hand behavior? That's another way to say it. What is in behavior? So let's change this up here and same thing though. FX. Left. So saying it a different way here, what's happening on the left-hand side? What's happening on the right-hand side? Okay with that? Low on that one? Avery?
So is it like only the first? So is it only the one with the first one with the exponent and understand the other one?
Perfect. Yeah, we don't care about what happens here because this does not affect the graph. Towards the end, it's just.
Like in example two, there's like there's other variables with exponents, but do we just ignore those?
To see what's happening at the end, started or the left hand and right hand side, those don't affect our graph.
Okay.
Hardly any.
So on the confusion test, we only focus on the very
And that's what the graphs on Desmos was all about, right? So
How it's ending though.
as far as what, go ahead.
How it's ending though.
On this one?
Yeah.
Let's graph this one here. So negative 12x to the fourth. So let's do it 2 different ways here. So this would go into this category right here, right? It's a negative number and it's an even exponent. So it should do this right here.
Negative number, even exponent.
Go back to here real quick here. So negative 12x to the fourth. I got that in there. Okay, so if I have this right here, if I start adding things to it, like minus, let's see, x to the second. Notice there's not much change to this graph, plus 3x plus 2. It's still, the end behavior still is the same. It does not change the end behavior of the graph. It moved things in the middle. That's about it.
We're only trying to find the endpoint.
Right-hand side, left-hand side, or in behavior. So starts and stops. Okay, with that, that's one thing done. So now let's start graphing this stuff here. So oh, you know what? One second. Let's let me get the. Or computer dies. I guess I should put it on.
I mean, in the spirit of Halloween. Let it die.
Oh, saved.
Let it die.
It's
Let it
saved.
die. Bro. What?
Okay. On the homework, it does say this right quickly here. So let's do, what example are we on? 4?
Math. What's it all about?
The graphs. So, oh, it's gonna be, so this one.
Positive number and end was odd, would it start high and end low? Or
Say that again.
if it was a positive number and end is odd, would it start high and end low?
It would start low and end high.
Oh.
So there's that, and C would be
Wait.
just X to the 5th plus 7. And so I have 1, 2, and 3. 3 graphs here.
For B, your graph goes down both ways.
That's in half.
A little negative there. Negative on that one. Talk about multiplicity in this class. Have we mentioned that any time? Sure, we did here.
Oh, someone dropped their calculator. You saying Clash Clans or your
All right, so we go. Let's see, ABC. So my question is, which one does A go under? A is matched up with what?
A is 2,
A is 2.
B is 1, and C is 3.
A is 2 because we start off low, is that right? And we end high eventually. B
Should be 1.
B would go with 1, right? It's an even function. They're going to be in the same, right? They're going to go towards the same values, either high, high, or low, low. And then that leaves us with C is equal 3 with a negative in front of it. Negative X to the 5th. It's going to start off high, and it's going to go then in low. It was a negative right there. Maybe if we should do the zeros here. So then, good there. Let's move on to graphing then.
Raja,
Yo,
so like in the homework, we're not gonna have to like graph like, you know, negative 12x to like 6 power like plus 24x or whatever. We're not gonna have to graph.
no, not those. If you are going to do it, then it says use a graphing utility to graph.
Okay.
So for these guys, we are going to have graphs to deal with here. I'm just looking up to see if they look at degrees here. So the easy ones are going to look like this. So we should know this is x to the 3rd power. These ones should be really quick, easy graphs here. This is goes like this, goes through 0, 0. Should go through 1, 1, and -1, -1. Are we good there? It's still trying to get comfortable with the graphing aspect. I know we did it all the way back in 1.6 and 1.7, right? So what does the little -4 do?
Right.
To the right. So can you move this little guy to the right? 4 units. So this one be 0, 0. This guy's 1, 1. This guy's -1, -1. But we're going to move it over to the right 4 units and see what happens there.
4 upon the 0. 4, 1, 3 on a negative 1.
Okay, so we have to find
My
zeros
math
here.
might not be right.
Okay. So how about I move each of these guys to the right? So 1, 2, 3, 4. So how about this little guy now is at 4, 0? So this little 1, 1 now is going to be at 5, 1. Agreed or disagreed? And this guy is going to be at 3, -1 now. But same exact graph, comes up, touches, and then keeps on going. We good there. All right, and this last one here, what do we do here? What's happening here? Man, we're pretty sophisticated. We're graphing stuff like x to the third stuff. That's cool.
Start lower.
We know that eventually it should start. It should start high and low eventually. But what's going to happen from here, right? That little negative in front, what does this guy do?
No, flip it.
It's going to flip it upside down. So we have ourselves this kind of graph. And then we're going to do what? We're going to add 4 to it. What does 4 at the end mean we're going to do? We're going to shift it up 4 units. So 1, 2, 3, 4. So bam, how about 4, 0? No, 0, 4. How about 1, 3? And how about -1, 5? Are we good? Okay, jamming. We are cool because now we can graph stuff like that.
Okay, now I'm confused, because I thought with a negative number and n is odd, it starts low and ends high.
Let's go, let's go. Let's go look at our notes. Let's go look at our notes here. That's even, that's odd, I think. Lindsay, let's go with it here. So if A is a positive number and N is odd, we go low, high.
Yeah. Wait,
And if that's with A being a positive number. With A being a negative number, starts high and then ends low. That's the second example that we did for the leading term test.
yeah.
Good there, Lindsay? Does that make sense? Now,
Because
No.
I don't see the negative number.
oh yeah,
Okay, because okay, yeah, I see.
cool. No problem. Do you have a question?
So basically, like, for linear graph, the increase and increase is like the same for negative and positive.
Say again.
So you start low and end high for a negative because it like falls out of the zero or something. Sorry, no, that's for positive. So, like, increase and-
You can think of it that
Follows
way.
direction because-
Yeah, so let's do that. Why does it do it? Because if you go to negative numbers here, let's say -5, right? If you take odd powers of -5, you still end up with a negative number. But then if you're multiplying it by a negative number, it jumps up to a positive number. That's the reason behind it. Does that help? Okay. Okay, so let's jam the other way. So we got to take care of that. Let's now jump with zeros. So let's go backwards based upon zeros here. Exercise 6. Find a polynomial function that has the given zeros. So what I know about this graph, I know this graph has zeros at 2 and 4. So now I don't know the end behavior. I just know if I were to graph this guy, I know that 1, 2, right here, it crosses the x-axis, and at 4 crosses the x-axis. And I also know it only has 2 zeros. It only just has the 2 and the 4. So notice, let's go back real quick. Let's go back to here. Notice what we did over here. If you just move stuff over to the right-hand side, so notice the 0 still stays as a 0, right? Right there. And so when we do this here, we say to ourselves, well, if that is a 0, I know that somehow this function had to multiply at the very least, it had to be a movement to the right. And there's another 0 we could. Jaden, does that make sense? All we got. There's a whole bunch of multiple answers. We'll actually look at some right now. But let's multiply this out. So in order to multiply this out, this would be what? X times x is x squared. X times a -4, -2 times x. And then a -2 times -4 makes a +8. So here's my function. That's just one of a whole bunch.
So we can't leave it just x minus 2. That's not.
Yeah, I think in the back of the book they make you multiply it out, but let me just check just to make sure for this one. 47. Unless they're just gonna say multiple answers. Yeah, so for these in the back of the book, they have you multiply them out, but there's a whole bunch of different answers. So let's take a look at them. So class, real quick here. My question to you guys, if I multiply everything through by 3, will affect, actually, let's do this here. Let's graph it. Let's graph in decimals. Let's see what happens here. I'm looking at the zeros themselves, right? Let's wait for it to connect here. Erase all this stuff. I have myself, you guys help me out here. X to the second, what? -6x? +8, are we good? Did they go through the zeros like we planned? Hey, right there, 2 and 4. Okay, question. If I make this little guy right here a 3, will it still go through 2 and 4?
Yeah.
Ready? Raise your hand for yes. Cool. Quick little raise your hand for no.
Wait.
Okay, there you go. Ready? 5, 4, 3, 2, 1, and
Whoa.
where did it go? It jumped all the way up there. That's weird. Okay, so hold on. Let's erase the 3 again. If you made a 3 multiply the whole thing, let's see. So if I multiply 3 times 3 times 3, oh, if you make it a negative, that's right. Hold on. Make this a negative, it goes like this. Yeah.
So when you put 3 in front of it, we have that expression. Does that mean that it has no zeros?
Correct. Yeah, it won't have any zero. Okay, how about this, class? If I multiply everything through by 3, so this would be a 3 here. This would be an 18, is that right? And that would be a 24. Do I hit my 2 and 4? Oh, cool. So multipliers all the way through would actually give me that. Okay. How about if I do a negative multiplier all the way through? So if this was a -3 plus and a minus, true or false?
Yes.
Okay, so multiplying numbers all the way through would give it to us. Let's see what else. Let's see, how about if we multiply by x? This whole thing, nah, that would, because that'll change our integer value, right? Our degree value here. So let's go back over here.
Dividing.
So Jaden always wants to divide. I'm not sure why.
If it's multiply, then I assume it would work the other way.
Yeah, and dividing would be like multiplying everything through by like 1/2 or something like that. I would still do it. Okay, so this right here is an answer, but then you also know that you could also make a multiple different answers, right? So any multiplication of another integer here, but we want to go with like the basic one. That would be like the basic one right there. Okay. Got to do this one here. So B, all yours for this one. I got a 3 as an answer, -4 as an answer, a +4 as an answer, and then, yeah, we've got to do 0. So if I'm looking at zeros only I can build off zeros is if I have parentheses, is that right? And I can say x -3. That would be one form of that little 0 right there. This would be x +4, x -4. Oh, this would be interesting. It would just be what? X, just x. Okay. And I am pretty sure they have you just multiply all these out.
That's not fair.
Like it's changed.
I have to multiply all that out.
So I just want to make sure that that's true. B.
How would you multiply this? Would you like cut it in half and then multiply this?
Oh, that goes over here. Which one would be easier to multiply?
Kind of split it in the middle.
Cool, yeah, I think I'd multiply these guys first, because what's x +4 and x -4 going to give us? X squared -16 maybe? And then if you multiply x -3 times x. You could just get things more complicated into it. And then you don't have to go everywhere. So the x will multiply just one of them, right? All right, almost done. Let's go with x times x, x to the second times x to the second, x to the fourth. This would be minus 3x cubed, minus 16x squared. What, plus 48x? Is that what we have there?
48x.
But anyways, do we sort of get this little concept that if you have zeros, they're going to be, so hold on, if you go backwards, if you did factoring, right? If we did factoring here, notice what happens, we would have had those as our factored form, right? So it's really about factoring going backwards. Okay, so how about this? Okay, we're good there with that one? Next one, I need a formula. Let's see, x is going to be equal to 3, but I need it to be a degree 2 polynomial. I have only one 0. It's just x equals 3. But I need this guy to be a oh, that's good. So if I would have did it like I did last time, I would have done like this right here, right? X minus 3. Except I need it to be a degree 2. So notice on these two, real quick, let's go backwards here. So notice this one eventually wound up with a degree 4 polynomial, right? Because there are 4 zeros. This one eventually wound out to be a degree 2 polynomial because of 2 zeros. This one would be a degree 1 polynomial, right? But I still want 2. So only way to do it is if we add a second 0 just like that.
We don't really get a degree.
What, like, what's the goal of a degree 2
Is that when you multiply this out, you get x squared minus 3x times another minus 3x, and then add 9. So notice this is a degree 2 polynomial, but the only zeros this thing has, if I were to graph this over here, it would do something like this. It would come down, it would just touch right here at -3 and come back up. So my only zero is at -3, but it's still a parabola at the end. And if I were to multiply this by any kind of number, it would be okay, right? It'd be the same thing here. Okay, try this one.
What is degree 2?
Degree 2 is this little guy right here. It's the highest degree on the polynomial. Okay, so you guys get this one here. Let's see. C, D. D is I have a 0. I have 2 zeros. 1, 5. But I want this guy to be a degree 3 polynomial. Yes. Ethan?
Oh, yes, you want to do now or? Can I go?
Yeah.
Bye bye, Ethan. Bye bye. Bye bye.
All right, so you guys are gonna have different answers for this one here. So let's see, we have, because of the 0 here, we have an x. Because of the 5 here, we have x minus 5. Except we only have 2 zeros. We need one more. So your choice, which extra 0 do we want here? We can write an x in here, or we can write an x minus 5, right? We need one more of those zeros. So we can either double up on the x or double up on the 5. I think we double up on the x. In fact, actually, let me do it 2 different ways. Let me go like this. X minus 5 and another x minus 5. Good there. If it's like this, I think x and x can go together as x squared. And I got myself x to the 3rd minus 5x squared. Good there. The other way would be if you multiply the x minus 5s together. This gives us x squared. Let's see if we guys can do this in our head here. X times the negative 5 is negative 5x. Another negative 5x, negative 10x. Negative 5 times negative 5 is positive 25. Okay, are we good with that? Hold on, so we'll graph this here. So that means we have zeros at, yeah, go ahead. So let me do this here. If these guys both have zeros at 0 and 5. Let's take a look at the graphs on these guys. So x cubed minus 5x squared. The 3rd power minus 5x to the 2nd power. How's like that? Are we good with that one? At 0, is it? Notice right at 0 though. Notice at 0, does it touch or does it cross?
Where?
At 0.
Yes, it touches and drops.
Yeah, it just touches right here, huh? Look at that. It just touches
yeah,
there
touches,
and then
not
it
cross.
turns back around. At 5, actually crosses right at 5. It goes from the negative side to the positive side. Okay. Let me go. The next one is x cubed. You guys have to help me out here. It's x cubed, then what? Minus 10 x. Help me out here. What's the other one? Minus 10x squared?
Yes.
I think it's plus 25 x. Okay. Do I still hit my zeros?
Yes.
Yeah. The weird thing is now, when is it crossing? When is it touching? Now it crosses at 0, right? Now it only
Touching at
touches
5.
at 5. So we'll have to see what that is all about a little bit later on. Class, I am going to change up the homework entirely for this section. But I don't want to do the zeros yet.
Thank you.
So for 2.2,
Could you email us this question?
yeah, I'll change it up here. I'm gonna go. You guys are only gonna go only up to 65.
Are you gonna post that on the?
Yeah, I'll give you guys a new homework assignment sheet. Now, honors question, you still get 91 for honors,
How lovely.
but
Hey, you signed up for all.
only
Yeah,
65.
true.
I change it up.
This is the easiest one I've ever had. No regrets. I don't have to read a whole last book.
What?
Exactly.
Thank you, Mr. President.
I'll share you guys.